Welcome back, my friends, to the show that never ends. We're so glad you could attend. Come inside, come inside. There behind the glass stands a real blade of grass. Be careful as you pass. Move along, move along. Come inside, the show's about to start. Guaranteed to blow your head apart. Rest assured, you'll get your money's worth. Wait is show. It happened out at the RC show. It's a dynamo. You gotta see the show. It's rock and roll.
Good afternoon and welcome to another episode of MetalForming Live. This one with a little different spin from last year's episodes. I'm Brad Coogan. I'm the editorial director of MetalForming magazine at the Precision Metal Forming Association. And today, senior editor Lou Kren and I are pleased to welcome you to MF Live on the shop floor, shining the spotlight on automated metal forming operations at two manufacturing companies. So we will begin with automotive supplier of stampings and wire forms, Clips and Clamps. Clips and Clamps recently installed a 3-robot multi-process lean production cell. And then we'll hear from an OEM manufacturer, Sukup Manufacturing, which has about a year or so under its belt using a 6-axis industrial robot to automate a 2-press stamping operation. So in each of these two cases, we'll start with a brief overview of the company, then a description of their specific automation projects. After that, we'll share videos that each company was generous enough to provide to us, and then you'll be able to see the automation systems in operation on their plant floors. Finally, we'll ask the folks with us today on our panel today from each of those companies to share some of their perspectives, not only on these specific projects, but also to talk in general about how they see automation making an impact in their press rooms and in the stamping environment in general. Lastly, we intend this production to be very interactive. We've got about 60 or 70 of you online so far, and I think more will be joining us. We really want you to use that Q&A feature on your Zoom screen to ask questions of our panel. And again, make this as informative, instructive as possible. Lastly, I would definitely want to thank our event sponsors, without whom we would not be able to develop and produce these types of educational events. So our sponsors for these sessions are CoPress Equipment, Schuler, Shea, Wintris, Greenert, and OnRobot. Again, thanks to every one of these great companies for their support of Metal Forming Magazine and of the Precision Metal Forming Association. All right, so without further ado, we'll go ahead and ask our panelists to introduce themselves. We'll start with Lou Kren down on the end, and we'll work our way forward.
Hi, Lou Kren, senior editor with Metal Forming magazine.
Good afternoon, everyone. Jeff Asnavorian, president of Clips and Clamps Industries.
Craig Rice, director of manufacturing at Clips and Clamps Industries.
I'm Will Healy. I'm with Universal Robots, as well as AMIP in Cincinnati, or Workforce Association in the Cincinnati metro area.
Tom Stocker, Director of North American Sales for Yaskawa Motoman Robotics.
And then we'll ask our two gentlemen that are joining us online to introduce themselves as well. Matt, why don't you go first?
Hi, Matt Cook, Sukup Manufacturing Company.
And then go ahead, Tom.
Hello, Tom Christopoulos, president of IP Automation.
Excellent. So again, thank you to our panelists for taking time out to be with us today and to share their insights with our audience. So we'll go ahead and start with our first case study. We'll start with Clips and Clamps. So Clips and Clamps Industries is based in Plymouth, Michigan. They're a metal former with expertise in wire forming in particular. And as it says on their website, they are engineers by trade and by passion. Clips and Clamps performs an array of processes, including CNC wire forming, stamping, welding, and assembly. So today we're joined by Jeff Asnavorian, as you just heard. He is the company's president, and Jeff also is PMA's 2023 chairman of the board. And joining Jeff today is Clips and Clamps Director of Manufacturing Engineering, Craig Rice. So Clips and Clamps was founded in 1954 by Jeff's grandmother, Estelle Duell. And Jeff credits the continued growth and success of the company, which is nearing its 70th anniversary, to the engineering mindset established by Jeff's father, Mike, who served as company president from 1985 until Jeff took the reins in 2016. And by the way, Mike Asnavorian also served a term as PMA's chairman of the board. So Jeff and Craig are here with us today because of the firm's newest addition to the plant floor, which is a 3-robot lean production cell, which performs 6 value-added processes. Describing the leap of faith investment in the cell added to the floor in 2022, Jeff Asnavorian told me that as Clips and Clamps continues to evolve, we're going to turn into more of a technology company than a manufacturing company. Of course, Jeff credits the production team at Clips and Clamps with the ability to quickly move that firm's new robotic production cell into operation. So as you're going to see in the video, after Jeff gives us a little bit more information, the cell completes numerous operations, including wire forming, cold heading, stamping, coining, piercing, and resistant spot welding, as well as a final inspection process. And then, of course, joining Jeff and Craig today on our panel is Tom Christofilos. He is the owner of IP Automation, which is the company that helped Clips and Clamps manage the integration of the cell. So gentlemen, welcome and thank you for being here today. I will turn things over to Jeff.
Thanks, Brad. So give you a little more background. This project started almost 2 years ago with a request for quotation that came into our automotive supply company. And it was a wire form project, something that Clips and Clamps Industries has been doing for over 20 years now. Upon evaluating this request for quotation, we quickly realized that this was something much more than just a wire form, CNC wire form project. Multiple value-added operations added to this wire form we knew right away would complicate the process. The volume on this automotive program was very large and was going to necessitate, we knew, at least some level of automation. Several million pieces per year are due to go out the door when this project reaches peak volume very quickly. We have previous experience doing value-added operations to wire forms in an offline environment, utilizing direct labor in order to be able to do that. We knew that that would not be possible in this instance. So this high volume also dictated the need for standalone equipment to help support this process, including a brand new press, cold heading equipment, resistance welding equipment, and a new wire forming machine itself. That's what led us to Tom Christofilos and IP Automation. IP is, and it has the industry know-how and is producing the wire forming equipment, but not just that, they have extensive knowledge in the integration of the value-added processes and automation of those as well. So we utilize them as our automation partner. The result was a fully operational automated cell that was launched in the last several months, and what? PPAP'd on time. Yes, so that's makes us smile. So to give you a little more detail, I'm going to hand it over to Craig Rice, and we're going to show you a video that will highlight some of these operations.
Thanks, Jeff. Let's review the basic process. The basic process. Almost there.
Yep, there we go.
Basic process is wire forming machine bends raw wire into shape. First part handling robot picks wire form and places it into the cold header. After heading the part is completed, the part is placed in the second transfer nest. Second part handling robot picks part from the transfer nest, places it into the press, point and piercing. Third robot picks stamping from bowl inline and from the wire form transfer nest. Parts are then welded together. Assembly is then finally inspected. If it's okay, part is placed on the part exit. The wire forming process in detail, part geometric data is entered to the HMI based upon each part's bend, straight length, desired bend angle, and plane change from previous bend. When part has been completed, wire form signals robot to pick part. Once robot is placed and has gripped the part, robot signals wire former that's in the grip position and okay to cut the part. The part is then cut free from the machine. Robot takes part to the next station, signals wire former once it's reached a safe spot to start the next wire forming process, as you can see here. Second process in line is the cold heading process. Robot places part into the cold header. After part is placed, robot signals to cold header to head the part. Once cold heading is completed, machine signals robot to remove the part from the cold header. Part is then placed into the next transfer nest, returns to the pre-pick point. Point and pierce operation detail. Robot picks part from the nest and places it into the press tool. Mechanical locators help precisely locate the part in the tool. As in previous steps, robot and press handshake to either cycle the press or safely advance the robot. You see here the press going up and down, pointing and piercing. The next process is inspection. Robot places part into the camera chamber. Based upon the part number selected on the HMI, camera will verify separately hole and or bracket presence. If part is judged okay, robot places part on the exit chute. If part is judged to be N-okay, part is dropped in the scrap bucket for further processing. Process will stop if a pre-programmed number of rejects are found within a set window manufactured parts. That is the whole process.
Very good. Thanks, Jeff and Craig. So very complex cell, right? And I'm sure you needed a lot of support from Tom's team at IP Automation. But tell us a little bit about, in light of the complexity here, I'm sure what turned out to be, an integration challenge, to say the least. How you grew the in-house knowledge base you needed, and how that combined with Tom's team at IP to integrate such a complex cell.
Yeah, I can start with that. So Clips and Clamps Industries was not completely naive to automation. We have a robotic MIG welding cell. We have pick and place robots for very specific, part-specific assembly operations and whatnot, but an integration and automation project to this scale had not previously been tried before Eclipse. So what we brought to the table was our knowledge that we needed to think about integrating this and to automate it in order to even be able to effectively quote the part for our customer. But we also brought to the table the knowledge of the pointing and the piercing. We're Stamper. Okay, we brought to the table the knowledge of the wire forming process, which we've been doing, like I said, for 20 years. We do lots of resistance welding of part on part. So all that stuff came to the table, but then it definitely required the use of a very trusted partner, which ended up being IP Automation. That's kind of how we got to where we are today.
So I don't know, Tom, do you have any comments on the knowledge that you brought, but also, I guess, what you saw in terms of the knowledge base at Clips and Clamps and what you were able to, I guess, help them understand in terms of integrating, not only integrating a process like this, but keeping it, finely tuned and make sure it's operating at, at its peak performance.
So the most difficult part of a process like this is probably the point and pierce station, as there's a very multiple part numbers that have to be changed over quickly. There's a lot of ownership that's got to be taken over to tooling for a long term for stamping. I mean, Jeff's team is great in that industry. Again, he's got the wire forming experience. He understood the variances they have to deal with wire when he took a project like this on. Both teams identified the issues that were going to come up and try to address them as best we can in the beginning. Of course, in any project, Always little things are gonna pop up. We had weekly meetings, communicated, both teams communicated really, very, very well to basically address these things as they came up. As the last check is the vision at the end, right? No one wants to be able to have a person at the end check everything. So that vision also helped a lot as well. And in between each process there on the nests and stuff like that, if something did go wrong, it's going to catch a process before it goes, haywire. But again, this is a big project because there's a lot going on, a lot of variables. The changeover has to be quick. It's got to be very repeatable, right? And that's the most important part of an automation project is the repeatability of it, right?
Sure.
So, and that's what the one thing that Jeff's team really understood really well was the wire forming part. I mean, we don't, for people who want to get into wire forming for the first time, maybe something like this is a little bit too much, I'd say, because it's just such a new, different industry than just, I think, stamping. Wire forming is a little bit different, but I think Jeff's team took that challenge really well.
Thank you. Yeah, so I'm sure you make it sound like it was pretty smooth, but I'm sure there were some unexpected challenges along the way. Can you guys share with us, if you will, one or two or three specific lessons learned throughout the integration process, some challenges and how you were able to overcome them?
Yeah, I can take that. It took us a while to find the base plane on the long wire form part. Typically, when you're developing a part, base plane usually is in the beginning or the end. And in these parts, we happen to find it in the middle. And once we found that, it was a lot easier to start programming part out to the end. So it was a little unusual in that. And once we discovered that base plane, we were able to change the locators in our dies to locate off that base plane as well. The other thing that our team realized is that when we first designed the tools, they were designed for basically perfect parts. And we had to open up a lot of the locators so that we could allow for part and process variation. So we wouldn't be constantly reprogramming the robots for slight changes. Once we discovered that and got that down, the process is certainly much more robust.
When you say locating the plane, is that more a factor of getting the part in the fixture properly, or is it programming the robots?
Programming the part, actually. So getting to program the wire, you usually start from the beginning to the end. You kind of got to work your way through it. In this case, we actually started in the middle and worked outward, and we found it to be, we could tweak the part within maybe a half hour. But when we first started trying to dial in the process, we found ourselves working hours just trying to get the part dialed in. And with a part with 16, 17 bends, if you don't get the strategy right, you chase your tail.
And you're doing two different lengths wire forms, right? There's a longer part.
Yes, there's a long part and a short part.
I thought did you tell me something about the longer part? Because it's a wire form that flexes, and so locating it in the fixture was a little tricky.
Exactly. So wires, and as Tom alluded to, it's not like stamping where it's very hard and very constrained. Wires is like a living and breathing part. It's almost like trying to push a noodle along a table. So when we're trying to locate something that's very flexible in the die, locators have to allow for that flexibility, both when the part's moving into place and then just letting it kind of find its own location. It's almost like horseshoes. You gotta just kind of throw it in the die and it's got to locate itself every time.
So that was you came up with a tooling solution.
We did it with those, reducing some of the overly constrained areas and adding some locators in key places.
I would like to add too, that, part of this, the working conditions between IP Automation and Clips and Clamps Industries, IP is sometimes waiting on us as the customer in order for us to get our tooling right to make sure that they can continue to go forward. This is all while working within time constraints, working within quality constraints, and having that right relationship and that constant communication, like Tom alluded to on our weekly meetings and stuff, was absolutely critical. There were times when Tom's team was waiting on our team in order to make sure that we had our stuff together in terms of press tooling.
Sure. Tom, are there other, so this is, you know, that fixturing locating problem with a manual operator loading the parts is not really an issue, right? That's more a function of automating the process, right?
It is, because a human can sense that the part's not in there correctly.
Right.
Robot's going to the same spot every time. It doesn't really know whether it's correctly located.
Imagining that was somewhat unexpected at the beginning of the process, and all of a sudden it's like, how do we deal with this?
Yeah, it was.
So are there other examples, Tom or Craig or Jeff, of that type of thing that you might take for granted when taking a manual process and automating it? Anything else come to mind, or no?
There's definitely a lot of, like Craig said, the variation is a big part of it. But something I want to add to this is in any process in automation, and we always look at it when we do it is don't box yourself in designs. Always allow for customers changing parts on your, in this case, there was a change midstream, big change in the wire form. And the good thing is that Jeff's team accounted for that in ordering of the press. A lot of little things that we made room for, even on our side, we make sure that we always have a little bit more room on stuff, because halfway down the project, if GM or Ford or whoever wants to change something, you don't want to throw away all the work you did and start a, whole argument, who's paying for what. So that's just want to add on that.
Excellent, thanks. At this point too, I want to invite our audience, if you've got any questions for the Clips and Clamps team and Tom and IP, please go ahead and use that question panel on your go-to screen to ask questions. Now would be a good time to do that. Another question though, Tom, again for you then, and I think you started to talk about this a little bit maybe, the type of homework that you would like to see a customer do before they get too far down the road with a project like this. What kind of advice can you offer to the people attending today, before they embark on a project such as this one?
I think you really have to do your homework. Number one is if you're going to try to automate a project, this processes, is it repeatable, right? I mean, you can't have, if you manually do the process and you have a lot of variability in it, you're probably going to fail at automating. And I think that's other people think you can just automate. Oh, well, if you automate that and make it perfect, and as Craig said, the locators, you have to adjust this, you have to make a lot of tweaks and that, but those are attainable, right? But if you have too much variability in the process, then it's like we can't bend the wire form and the part had 6 or 7 more bends in it, and they want to hold a tighter tolerance. It wasn't possible to automate that, or we needed a different bending sequence or philosophy. So that's the most important part.
Terrific, thanks, Tom. So we do have a couple questions from the audience so far. The question is, do you have any real-time monitoring and adjustment of the wire forming within the process, or is it programmed once and then it just runs?
We're so good at program once and it runs.
Yeah, I mean, you've got 2 parts.
But like Tom said, so the part locating nests and the nests in the die, the part doesn't fit in that. You're already poking mechanically the part in itself, and then if you can't inspect it, the camera's going to catch it, and we'll shut the process down.
Okay. Jim or John, I hope that answered your question. How much variation have you found to be in the original quoted price for an automation project versus the final price, the working cell after development? I'm not sure who wants to handle it.
Tom, you want to take that one?
Throw Tom under the bus.
To be honest with you, we were very close in our initial budgeting to where we came out at. The only thing that caused extra cost was the aforementioned engineering change that came from our customer in the middle of the project launch. Now that could be potentially foreseen, not what it was, but the fact that it could happen. And so obviously we were able to recoup those costs, but outside of that variation, I would say we were probably within 5% of our budgeted cost.
Tom, do you want to add anything or you want to dodge that one?
Well, no, I will tell you this, as a company, I totally understand when someone takes, when someone quotes a project, our job is to make sure that we quote something that is gonna meet their goals, right? Because if you don't, you're not gonna get a second phone call, the next project comes up, right?
Yeah, I mean, it was absolutely critical. I mean, we had to rely on those quotes in order to know that we could quote the part correctly. And if any of that was blown, then the entire project would have been in jeopardy. So, yeah, absolutely. It was a good partnership. Not afraid to answer that question, actually. It was a good outcome.
Thanks. Tom Stocker from Motivated.
Sure. One thing I think when you see whether it's, call it scope creep or change orders, that ends up costing the end user more money. One way really to reduce that risk is to have a defined scope of work when you go to an integrator or a partner to have equipment designed and built, especially if it's custom equipment. As the end user, especially if you're new to automation, there is inherent risk there, but defined scope of work, understanding your products, your cycle times, it helps immensely.
Thanks. A couple more questions and then we'll move on to our next case study. Spring back of the wire, is that an issue? If it is, how do you accommodate any spring back issues?
Overbend. I mean,
But in terms of, I guess maybe in terms of automating the processing, you've got maybe unpredictable.
It's pretty consistent within the coil for the most part.
Okay.
And then once it starts to go out, make an adjustment and it'll run consistent for a while. But wire's a living and breathing thing. So you just kind of gotta play it as it comes. It's difficult to predict what's going to happen.
Much more variability in a coil of wire like this than a coil of strip steel.
Is that right?
Oh, yeah.
I guess I was done that.
Oh, yeah.
Plus, you're kind of working in metal, in die forming. You're kind of like we're bending in air on the wire former, as opposed to hitting against two hard pieces of steel. So material variation is much more noticeable in wire than it is in a coil steel.
What was the timing of this? When did the full integration take place? And did it occur at IP first, which I think it did, right? And then they moved it to your floor?
Okay, so absolutely. So I mean, in any automation project, well, you got your statement of work. The process, we worked with Tom, we had a couple of meetings and actually went on that floor a few times to make sure that the runoff, everyone knew what was going to be required of the runoff, how many parts we were going to run. And then when we did our runoff, we brought the statement of work with us so that we can walk through all those objectives that were agreed upon. And of course, you want to run off on their floor because inevitably there's always going to be things that need to be changed. They're going to have their own open issues list. It's easier for them to knock those items off on their floor than it is bringing their crew to an offsite location. So yeah, that's key.
Process cycle time. Did you have a real good feel for that before the quoting process, or did you quote with not really a full understanding of the cycle time that you were going to do?
We quoted very knowledgeable of the process cycle time. That plays everything into this part. And again, it was a reason that pushed us to automation and integration to begin with. And we are there. We're hitting it and or beating it in some cases. No, well, there's four parts. It's not everything, but we've hit our targets. Let's put it that way. Yeah.
Okay, so one last question before we move on, and we will have time at the end of the second case study for additional questions. So please keep them coming, and we'll make sure to address them at the end of the final presentation. So the last question for now is kind of following up on locating the parts and the fixtures and that kind of floating gauging that you have. So how does the robot account for any float needed to get the part into the guides? Does it let the part go and settle into the fixture, or is it somehow
It actually holds it in place, but the mechanical locators do the fine locating as opposed to relying on the robot to do that. The part just kind of slides, gets it into position. Fine locators let the part slide into the final home position.
All right, well, thank you, everybody, for your great questions. Again, keep them coming. For now, I'm going to turn it over to Lou, and he's going to introduce our next case study.
All right, thanks, Brad. Good stable pricing of agricultural commodities, such as grains over the past few years, has meant steady demand for grain storage and handling systems and equipment. That's good news for suppliers in this sector, including Sukup Manufacturing Company based in Sheffield, Iowa. Helping to meet challenges of increased customer demand in these areas and to counter rising steel prices and the shortage of skilled labor, Sukup Manufacturing has embraced pressroom automation. This includes installation of a Yaskawa Motoman robot that stacks blanks and tends 2 stamping presses to produce flooring supports for use in grain storage operations. Here to tell us more about Sukup Manufacturing and its automation journey, and to provide details on this press room robot setup is Matt Cook, Chief Marketing Officer for Sukup Manufacturing, and Tom Stocker, Director of North American Sales for Yaskawa Motoman. Welcome, Matt and Tim. Matt, can you tell us a little more about Sukup Manufacturing and provide details on its press room automation efforts?
Yeah, you bet. Thanks, Lou. Appreciate being invited to contribute today. Sukup Manufacturing is located in Sheffield, Iowa, and we manufacture grain handling and storage equipment for farm and commercial sites of all sizes and shapes. Currently, we employ 850 people and process more than 1 million pounds of steel per week. And we utilize more than $100 million worth of automated manufacturing equipment across our 8 different facilities, and have product in all 50 states and over 90 countries. And we're celebrating our 60th year in business this year. And today we wanted to share a video highlighting one of our newest installations of our automated Superwave floor support cell. So this is a look, just a broad look at the cell. What we're doing is the blank that's in the stack in front of you is being picked up by the robot. It's going into a gauge check to make sure there's only one sheet there. It will flip around, and then it will grab the completed corrugated sheet, and then it will insert a new one. So watch it flip there. It grabs the completed corrugated sheet, it flips over, it puts the blank in, and then the press comes down. And on the other side, there's another press that puts further bends into this piece of metal. So again, check the gauge thickness, make sure there's one in there. The press will come down. It'll, or we grab the other one. Here's a look of the press coming down, and you'll see another look at it in a minute. But what's important to notice here is that we're actually putting in 9 bends, and as it comes down, what'll happen is it hits in the middle, and then it will kind of slowly make its way out. So I believe it's something like 27 bends are being put into that corrugation, within a few seconds there. So again, taking the old one out, putting the blank in. This is the opposite side, the secondary press location. This one right now is a look of when the corrugated sheet comes off the first press, and then this press comes down. It's a difficult shot here. The focus is a little out, but you can see that die set comes down and then further puts those corrugations in. So you can see it from this angle, a little bit easier to tell. We're kind of putting a wave shape or a W shape into that finished sheet. One thing of note here, we used to run this in separate cells, not using a robot. So we ended up having 3 employees on this process. And with the cycle count, we now make over 1 million of these a year. So it was totally, this started off as a prototype for us, and it ended up becoming something that we needed, a lot faster manufacturing cycle time for based on the demand. So here's a kind of a backside look at that first corrugator, and you can really see the engineering that went into this press, as well as, of course, the programming that went into the robot. But here's that blank sheet, again, flipping over. It grabs the sheet, takes it to the other side, and starts the process all over again. So again, checking that gauge sheet, going over to the press, coming down, grabbing the old one, putting the new blank in, and then repeating that process all day long.
Thank you very much, Matt. We do have some questions for you. Obviously, your company is well versed in automation. I think you said to the tune of $100 million across your 8 operations. With that in mind, looking at this case study, there is a lot going on here, namely double blank detection, being able to handle that size of blank, the sensing required for proper bends and everything else, and even moving that material out of the press. Could you talk a little bit about the challenges in this particular application?
Well, just like you kind of said, Lou, there's a lot going on there. As I'm a recovering electrical engineer, so signal processing and things like that is something that I'm very familiar with. There's a lot of variables to handle there, and a lot of different failure points. So there's a lot of subsystems that are employed there, a lot of check realignment, failure detection, and then alerting that goes on with it as well. So just one of the best things that we have in this is we have some firm fixtures which really help. So there's some quality control that goes into before those blanks can even get stacked in that stack, because you don't want, like in the first example, the last thing you want is an uncontrolled source. And I can say, as somebody that rolls both wire and sheet steel, Jeff's point was totally correct, and they are very different. And there's a lot of variability, especially as that coil rolls out. So we want to make sure that the raw material is as well vetted before it goes into the machine as possible.
And can you discuss any of the unexpected challenges related to incorporating press tending automation in this particular place, in this particular application? Maybe some things you hadn't anticipated or that you learned on the fly?
Well, definitely picking up one sheet at a time was one of the things that you just kind of take for granted initially. And just some of the things that you as a human will do that you haven't really quantified before you step into it. I think I see a lot of head shaking on that one. And this is just process inventory. And you end up learning a fair amount on the fly. We do have a lot of experience with this, so there have been a lot of things that we did catch in the beginning, but there are always those little things you didn't account for that that can, send the cost of a project a lot higher, especially if it's a redesign, which in this case it's not. But we've definitely had some automation projects that haven't gone to plan because of that very thing.
And Tom Stocker with Yaskawa Motoman as a supplier of Pressroom robotic automation. What was it about this application that that defined this type of setup, this use of robots and the handling and things like that?
Well, I think one of the things we want to look at in press automation, regardless of this application or just press tending in general, when you automate it, Matt alluded to, double stack detection. But one of the worst things we can do is load 2 parts into a die and damage the die. In addition to that, in other press tending applications, we have to handle scrap, or essentially the customer does. Automation companies like ourselves, we're experts at automation, not stamping. So what we rely on our customers, and this is where it's really a team approach between the end user and the integrator is understanding how to protect your dies and press tending. Get the scrap out of there. The robot's not going to know if there's a piece of scrap sitting on the die. It's just going to go and load it onto the next, the next part on top of that. There's potential for die damage. The other two things that we always want to be very cognizant of when you're approaching a press tending application, if it's a new press, you have a current controls package. So safety, wiring, and interfacing to your presses is probably going to be straightforward because it's going to be over an Ethernet network, most likely. If it's an old press, you're probably discrete IO, or that press could be 50 years old and you're faking old relays. So how do you do that safely, not have the robot arm crushed in the middle of a cycle? Pretty important stuff. And then the third thing I would sit there and say for anyone considering press automation is be considerate of your floor layout. You're going to have to get dies in and out for maintenance. Most likely your automation is going to be bolted to the ground somewhere around the press. So you want to make sure you're taking into consideration those factors as well as having automation in your floor layout. Usually older presses, they're already in a pit. You can't easily move them. So definitely those three things on any press tending application you want to be aware of. So, great.
Good. Thanks, guys. Yeah, so we do have a question from the audience, and again, this is a good time to ask these guys, kind of pick their brains. We've got over 80 people online, so please go ahead and ask your questions of our panel. We've got plenty of time left here. So the question from our online audience for Matt, have you encountered any issue with retrieving the formed part, particularly on the bigger pieces of steel? Are you measuring any of the bends, or are you just relying on a check fixture to gauge where you're at, or if adjustments are needed? Sorry, I guess that's two questions in one.
Yeah, so the blank that actually gets loaded into the machine is already checked for tolerance before it gets there. It comes from a one-hit blank, so we're always checking to make sure that that's the case. And then we've been very fortunate to basically just rely on the fixtures. The fixtures are heavy duty enough that there are stops and corners and things like that in the right areas to make sure that those sheets get lined up perfectly for each one of them. There are actually little fixtures underneath that will move the sheet if required. So that's in general how we're doing it. This application, didn't require any sort of additional adjustment beyond that, though we've had plenty of them that do require that. So it really depends on what we're doing. The nice piece, or the nice thing about this specific process, is that this always goes back to tolerance, and what's acceptable and what isn't. The application for this floor support is pretty wide variation for what you're going to need, as opposed to on our automated laser machines, where a 64th of an inch is a very big deal. So it just depends.
What is the overall equipment effectiveness of the cell, and are you having downtime issues related to material variations?
No, we're not having downtime related to material variations.
Your OEE, are you willing to share that with us?
Excuse me?
The OEE of the cell?
It's hard to say. We did have some maintenance that we did end up having to do with this, which was unrelated to the process. So I mean, I would personally have put the overall effective rating, above 99%.
Is it running completely unattended? Is there an operator in the area?
There's an operator in the area taking the sheets off. But in general, it's just kind of like, hey, we're all we're doing is retrieving the final product. So yes, there is an operator, but it's pretty much just making sure that the station stays full of blanks.
I'm curious, Matt, too, about, you're a pretty large OEM. You've got a lot of employees. So how big is your automation staff? How has it evolved? over the years, you must have automation engineers, I'm imagining, or some highly trained technicians. Talk a little bit about your support team to keep systems like this running.
Yeah, that's a good question. Our maintenance staff, we just call it our maintenance staff, which includes some folks that are highly trained in automation, mostly just, you know, seasoned veterans that have been around. I would say close to 20 or so different technicians that we have at different capacities, of our 850 employees, that are able to, in Sheffield, we have about 850,000 square feet of production space. And so getting around, I see the golf carts going all over with they have little beeping horns. So you hear them all the time, and they're going from one building to another, you know, just making sure that our uptime is as much as possible. It also has to do a lot with like the control side of the business, the automation control side. So making sure that whatever we're using is repeatable and familiar, and therefore, you know, when we as much as we can do ourselves, and then working with our partners to be able to do that.
Thank you. And so bringing people into those roles, making sure they're trained and or getting them the appropriate training. How did that work? Is that all through Yaskawa Motoman or through a local community college? How do you train an automation staff?
All of the above. We do have a really great tool and die school at our local community college about 20 miles away. We heavily subsidize the tool and die department to make sure that we're getting all of the, you know, the best graduates that are coming out of there. There's a lot of training that does happen with our partners as they come in, and just kind of gleaning off as much as we can, especially when those suppliers are, say, coming from overseas. You know, the last thing we need is something like that happening. So.
All right, we have another question from our online audience. Did you consider using a robot to unload the part after the final forming operation?
Yeah, so that's phase 2, and I think that pretty much everybody in here will agree that you start with figuring out how you're going to do it by hand, and then if the economics end up working out, you definitely want to automate it if you can. I don't know what it's like for everybody else, but there's a ton of low-hanging fruit, and so when it comes to equipment automation, I'm by no means the decision maker on this, though I have a significant voice in the room. You know, I'm looking for something that's the easy stuff, the 2-year or less payback type things, that just because there's so much to do or that can be done, but you start off in the doing it by hand, making sure that everything works right, and then you do what you think you're going to get the most value for. And given what our scope was to begin with, we said we'll make sure this works and then we'll implement another one. And so breaking these things up into cycles is also a big deal, because you might find that if you try to tackle it all at once, you have a bigger failure rate for sure, especially if you wanted to change the process down the line.
Did you want to comment on that?
Yeah, no, that's a great approach. We have, in my career, I have seen customers take on too much at one time, bringing in new technologies, and a lot of times they're not successful doing that. So a phased approach, one, you can train your staff as you scale up with more automation to new technologies. That's a very smart approach.
Great. Yeah, I remember in the article Lou wrote on this application, there's something in there about continuing to work with Yaskawa on furthering the production cell. Is that what you're talking about here, Matt, or is there more to the kind of the next steps that you're planning with this?
Yeah, we have another cell that we run for this one that I know that there's some progress happening there. We've done business before, we'll do business again.
All right, we don't have any other questions from the audience at this point, but again, feel free to, as you think of them, continue to ask. Otherwise, turn it over to Will, who's I know got some ideas and thoughts that he'd like to discuss with the panel.
Yeah, and I really appreciate the chance to be here. So I heard a lot of really interesting thoughts and advice for manufacturers, especially metal stampers looking to invest in automation, figure out how to invest in automation. I mean, the real first thing that I heard, and I've heard before, you know, humans are flexible and smart. And automation is a little bit less flexible than a human. So we heard, you know, the robot doesn't know that there's a piece of scrap in the die and we can cause some damage. So investing in things like die protection, which I've talked for years about at different conferences, investing in die protection becomes almost more important because there's not a person there as your vision inspection system anymore, right? And so you have to be paying attention to the dies and the materials that goes in. I like to say that the die is like your baby, right? The die set, you have to treat it like a baby. A baby, a mom and dad, I have 3 small kids, and a mom and dad, all they talk about is what goes in and what goes out, right? That's all you talk about all the time with that tiny baby, what's going in the front end and what's coming out either end. So you really have to think about that with the die set, right? What goes in, what must come out. And that's even more important with automation. And so as we add automation around our presses, die protection, something that I hadn't heard anybody say, but becomes really, really important part of all of this. I would also say I heard things like double blank detection. I mean, for the same reason, to protect the die and keep it safe. You don't put too much in one end. And then, you know, process consistency. I always love to ask people, what's in your documentation versus what do your operators do? And people are like, our operators always follow the documentation, which there are 12 steps that aren't in any of your paperwork, right? And when you go and really, maybe you document it now, but when you look at the paperwork and then you go and look at the process, there's very commonly things that somebody's doing that they've learned over time. They're sweeping the die with a broom pole every time, even though that's not in the documentation anywhere. And so really understanding your process, I think you made a good point, Tom, about documenting the scope of work. I think all of that, humans are flexible and smart. The automation is a little bit less flexible than that, and we have to think through all the things that people are doing. I thought that was really a good tip that both companies gave. I also heard teamwork with the integration team is really important. They both talked about whether it's an internal integration team or an external integration team, you have the process knowledge. You know wire, you know it lives and breathes. I didn't know that. I'm gonna watch it breathing next time. But you have the process expertise. And if you try to dump the whole project over the wall at the integrator and say, deliver me a perfectly functioning machine, it's not gonna work. And so I heard that too, that this open collaboration between the integration teams are really important, that you know your processes and they know automation. I really liked that. That was a really good quote, Tom. That's really good advice. It has to be this collaborative, open communication thing with a clear spec. And I really liked you said, we bring the spec with us and then check what's going on versus the spec. How many times do you write a set of requirements and then like never look at it again after the beginning? I mean, I really loved that philosophy of like, write your spec and then use your spec to do the checks. That's really smart. So, and then I also heard, you know, automation is kind of an evolution. I really liked it just a minute ago, you know, starting with the low hanging fruit and not biting off too much. You may want to automate everything, but it's better to make it steps and progress and phases than those other things. So I heard a lot of really good advice, but I have a couple of questions I've written down, Brad, and I appreciate you giving me the opportunity to ask some questions. But I'm going to start with Matt. Matt's out there, and Matt, you have it sounds like you have a number of automation investments. You know, how are you using automation to, you know, as a way to attract and retain young people into your organization? How is your automation and your technology investments, how are you using those as part of your HR strategy in your company?
Sure, it's a good question. You know, we play in a lot of different areas. You know, bending steel is definitely one of them, and that's our primary revenue generator. We also though have a significant investment in technology here in Sheffield and just across our company in general. And I feel like definitely from the professional world, they want to know that we're serious about doing things. I think that in general, folks that are trying to decide which job they should take has a lot to do with is the manufacturing process impressive, or does it seem antiquated? And when we're trying to recruit talent for that, it's hard enough in our geographical area, in general, especially for professional talent. And so, and we're saturated in general with, I think Franklin County, where we are, has sub 1% unemployment rate, so employees pretty much have their choice of where they need to go. But I think that like quality of life as an employee is, especially from the production floor, is a big deal. The manufacturing, the automation manufacturing equipment that we put in, making it easier for people to do their jobs, having a higher flow rate of material gives them a higher job satisfaction mentality, which is great. I can tell you from an engineering standpoint, I love rapid prototyping. So it's incredible that I can sit at my computer and pull open SolidWorks or AutoCAD or whatever CAD software I have, design a part, and then send it to my operator in a different building and say, hey, run this when the next time you've got a free space of 6 inches by 11 inches on an 11 gauge sheet, and you can have concept to part in an hour. Just things that are just, they just don't exist very well in our traditional OEM type business.
Cool, really interesting. So if I were to ask the same question over to you folks at Clips and Clamps, how are you using automation as a tool for recruiting and retention?
Yeah, absolutely. Clips and Clamps has been, I think, at the forefront of our internal education and training programs for years. Our company, just little self-plug, we're founding members of the Educational Foundation here with the Precision Metal Forming Association. Part of that is developing skill standards and making sure that we're training our team members so that they're most effective at their jobs. And just like Matt said, so they're getting satisfaction out of their jobs. Well, we all know as manufacturers, most of us, I would assume on this call and this meeting today, wage pressures have been insane for the last couple of years. Well, how are we going to afford as manufacturers to continue to pay our very valuable employees what they deserve to be making in this economy with this kind of inflation if all they're doing is holding a piece of metal and then moving a piece of metal, holding the piece of metal and moving the piece of metal? The bottom line is we're all working to upskill our employees and their technical skills. So, Clips and Clamps, in particular with this wire forming cell, it was a team of people. Take a look at the April issue of Metal Forming magazine. You can see a picture of that whole team standing in front of that wire form cell. And it was everybody from mechanical engineers and manufacturing engineers and tool and die makers and production operators and packaging people that all got involved in that. We did extensive training with various team members at Fanuc for robotics and over at IP and learning how to program the wire forming cell and how the integration worked and the robot controls and everything else. And hopefully I don't embarrass her. Maybe she won't see the video here, but just an example. We have a great industrious team member, and her name is Lexus, part of our team. She's been a production operator, a direct labor production operator with us for a little over a year and a half now, but she went out to IP and she is fluent in the operation and troubleshooting of this cell now. So we are absolutely upskilling that at every level of the organization. So it's absolutely critical to our HR strategy.
And I would add just a little bit to that too. A lot of cases when we talk about automation here, we're talking about the jobs that absolutely no one wants. Like no one wants to be able to unload that piece of steel all day long. You talk about repetitive work injury, you're talking about all sorts of things that you're avoiding doing that. So it just helps us repurpose and upskill. Totally agree.
Good. Can I interrupt you a little
Yeah,
bit?
go
We got
for
a
it.
few questions
yeah,
from the
awesome.
audience, a couple good ones here. So this question is specifically for MotoMan, but I think maybe Chris or Tom Christophilus can also weigh in on this one. So when you're hindered on space, and you talked a little bit about making sure you have space specifically for die changes, do you have ways to integrate the robot for a large press, you know, with limited space for die changes, that kind of thing?
Yeah, so there's a few different ways you can approach that. Automotive world, they'll do a die change on a line in under 4 minutes. That includes all the robot hand tools and the die sets, and they have a lot of their equipment, typically almost like railroad car tracks that goes through the press. Same thing with the automation, because especially if you're doing, you know, a work piece that's the bed of a pickup truck, it's pretty large. Other ways is we have some long range or long arm reach robots where the payload may only be 100 kilograms, but the reach may be 3.5 meters. So you're getting out to 16, 17 feet. And we can put the robot off to the side. And then with some longer hand tool extensions, we can basically, if I have a press here and a press here, put the robot here, I can reach into it this way, swing around. And then when you do a die change, I can park the robot so your bolsters are totally clear. One other method you could do too is invert mount the robot. It does cost a little more because of the steel structure, but you can have the robot above your bolster where now it's reaching down into the press and placing onto a handoff station, another robot, another press. So those are some of the options that we do have available to us.
Yeah, I'd add to that too, Brad. There's a category of robotics that's only been around since 2005, collaborative robots. And more and more, this is becoming an option. You don't have space around the press. You need the operators to be around the automation as well. Universal Robots is the first company to introduce collaborative robots into the marketplace as an option to work side by side with the worker, as an augmentation to the worker. So when someone's hindered for space, that's typically where maybe traditional automation doesn't fit the application or the budget. Then there are options for collaborative robots to be applied, and we have a lot of nice case studies talking about that, and how that's helped people in those situations.
I'm sure Niskawa, IP, and Universal, and every company here's this question. That it's great for high volume production, but can you share any insights or suggestions for bringing automation to lower quantity work? And I do think these cells are becoming more flexible and more programmable over time, but maybe you guys can comment on lower production automation projects.
So you want to go first?
No, you go ahead.
All right. So one thing for low volume, high mix production, you don't always want to be programming your every single part. So you're seeing a lot of on the market AI sensing solutions available that can identify the product, understand where to pick it, and then perform the motion profiles without having to define every part. So there's quite a few. You've seen a lot of investment. It's outside of metal forming, but in the logistics space, where you go to your FedExes, your Amazons of the world, where 3D cameras can basically identify, is this a box, a rectangle, a pouch, what the surface is, and identify how to pick up a product without a programmer ever touching this. And it's really, those technologies are really designed around high mix, even high speed applications. Where you can integrate those into robots to help, overcome some of the teaching tasks you would have to do. And I think that probably follows up right along with the cobot ease of use market as well.
Yeah, for sure. I think high mix, low volume is where cobot's sweet spot is, whether it's metal stamping or welding or many applications. That's kind of in between manual labor and traditional automation. That's where you find collaborative technologies have the best fit. So like we have a customer, they're a metal stamper, PMI. They had 3 days from a collaborative robot being dropped off on their dock to when they were actually running production, doing press tending. And it takes them about 5 minutes to teach the next part, and they got 3 times the productivity out of a person standing next to the press. And all the arguments that the guys have already presented about investing in automation, having the people feel like they're more valuable and having new skill sets, those kinds of things absolutely apply to that as well. I don't know if anybody else has thoughts on that topic.
Christophilus, did you have anything to add to that, or?
Yeah, so if you have a business that has a family of parts, we've seen the biggest amount of success implementing like high mix, low volume. We've done projects where we've done 27 or 28 different part numbers where they have to switch them over in 10 or 15 minutes. It's just understanding, and we like looking at that. The first step we do is for someone coming in like, hey, I want to automate this process. And I said, well, do you have any other parts that are similar to this? We can apply this through. And you'd be amazed. Some people, oh, well, this is the same, but this is different. Well, it takes a time to do an analysis. And if you can design the automation so it's flexible enough, the ROI is going to be that much faster.
Good, thanks. So, you know, the $1 million question always turns up when you think about automation projects, which is, are we replacing laborers with robot technicians? I suppose in many cases we are, but the question then is how do you deal with that with your shop floor staff? So it's really for Jeff and Craig and then for Matt. You know, how early in the projects did you involve your shop floor people with these projects? How did you assure them that their jobs were not being, you know, threatened? So if you guys could talk a little bit about the human aspect of adding automation.
Great question.
Yeah, great question. You know, again, I think I'll point back to my upskilling comment before. It's not that in this particular case, let's talk about the wire forming cell that we saw at the beginning of our meeting today. In this particular case, that wire forming cell would not be at Clips and Clamps Industries today if the automation solution had not been put into place and it was not successful. In fact, I would hazard to guess that that wire forming cell would not be in the United States of America if that automation process had gone through as well. The labor content involved in that without automation would have most likely pushed that to an LCC. Okay, so that's the first thing you try and make sure that your staff, your team members understand is that this is good for the company. This means further education for us, for you. It means further business for everything else. And we're only going to learn from this going forward. One of our other team members, I keep thinking about him in this process as well. I mean, he went to school to program computer games, and now he's programming a lot of our CNC production equipment instead. And there's going to be more and more of those opportunities coming. So it is not a matter of pushing general or direct labor out. It is still just a matter of making that gradual transition to the high technology manufacturing environment.
Did you involve people on the plant floor early?
Yeah, we did. I mean, I wouldn't say it was at the very beginning step. I mean, I think it was engineering staff at the quoting step, but once that project was awarded, they were involved. Absolutely, yeah.
They had to run it off, so they had to take ownership at IP and then take ownership at Clips and Clamps when it ran off as well. So their input was involved right from the beginning. If they didn't like the way something ran, especially at IP, we could make the change right then. So they were very much part of the process.
You took your operators to your integrators so they could do the runoff.
Almost always when I do a runoff, I do that.
Wow, that's a very worthwhile investment, but not one you hear a lot. Okay, cool.
Yeah, because if I can run it, if I learn how to run it, it doesn't
That
matter.
doesn't help.
Sure.
That's powerful.
Matt, how about you? Any comment on bringing the team along for the ride on this project?
Yeah, that's definitely, you know, part of it. We've got a pretty good model for how we do this now, but I would say we generally, you know, from a production management side, we have a pretty good idea of what project we should select. you know, a lot of the employees in general, our production employees, don't have a lot of the scope to be able to decide, say, which application we should choose next or whatever for automation. However, the moment I heard Jeff say that a second ago, when it's awarded or when we've decided that we're going to do that, the first people we talk to are the folks that have done that process forever, because it's process inventory at that point. When we're mapping out what needs to be done, they're absolutely the most important people. Yeah, we've got the automation engineers, or the manufacturing engineers rather, you know, that'll help us with this, but it's those fine details that you find out from the operator. Like I can't remember who said it before, but the step that's not published in the manual or in the documentation, that's where you find that out, which also helps eliminate the scoping problems and the process inventory issues.
Thank you. Do either of you, Matt or Jeff, care to comment on additional areas you're looking to address via automation? Do you have some more plans in place for your automation journeys? Jeff, maybe.
Well, I can tell you that we absolutely believe that this journey that we are in the process of completing right now is the first step. We don't have any active programs that we're looking to convert from current manufacturing process to an automated manufacturing process. However, new projects coming on board now, we are going to be looking at them with a much different set of glasses than we looked at prior to this project.
How about you?
Yeah, so for me on that one, it's three-dimensional welding, you know, is a big one. Welders are very difficult to be able to find as just as a skilled application, especially for, you know, the comment was, or the question was posed earlier, what do you do with, you know, lower volume type deals? That this is a perfect one where, you know, the labor that you're trying to have is expensive and hard to find, combined with a high mix of parts. Anything you can do that you are using cameras and AI to be able to help you determine what needs to happen before you do it or on the fly, especially with welding, is something that we continue to look at. We have several robot welding cells in Sheffield, but you know, we're looking to expand that in even broader terms.
Matt, are you standardized on Yaskawa Motorman robots? How did you select the robot for this particular application? Maybe talk a little bit about the process for picking the right vendor.
No, it's a good point there. We don't. Yes and no. There are. I know it's not necessarily a great answer. I'm talking out of both sides of my mouth on this one. But we definitely have you know, we like certain brands for certain applications, and we like certain we want the standardization in process for sure. So have done lots with Motorman.
Tom, how about you? Tom Christophilus.
So we've done Motorman in the past. We tend to just, as an integrator, we tend to pick FANUC as our default standard. Certain customers, you know, have asked us in the past to use Motorman. Those are the two basically brands. This is where we teach our technicians, our core people, our programming, because we do a lot of our machines talk to the robots directly as well. So there's a lot of work we do on our front end to handle that, and we kind of like to default to one brand. But in the future, you know, as the big issue is that to talk to one brand of robot, another brand of robot, it's probably going to be a different way of, you know, different programming. When they all standardize it, then I guess it'll be a little bit more easier to switch brands.
I mean, you guys didn't really
I come from
have a preference.
place where we standardize PLCs as much as possible, standardize robots. Simply for the fact that when you're looking for PLC technicians.
Sure.
Most of them know Allen Bradley in the US. We're going overseas, they all know Siemens.
Right.
So trying to find one that knows both can be a challenge sometimes. And from robot programming, you only have so many technicians in the Detroit area. Fanuc is down the street. It's a lot easier. Most people know it. And parts are fairly easy to get a hold of as well. If something blows up, I can call them. So we try to standardize.
Thanks. Got a little bit of time left for more questions. Will, I know you've got some more.
Oh, yeah, I got lots of questions. I mean, I could ask questions all afternoon. I think, no, I mean, we talked about a lot of different things, but two of the, what I realized while I was sitting here thinking and listening to y'all, it kind of seemed like you guys bought whole new equipment for the line that you were doing. And the impression I have from Matt is, Matt, you guys retrofitted some equipment you already had. And so I'm kind of curious from both of your views, because we have two different end results. How did you decide whether to buy all brand new equipment for the project, or how did you decide, we can use what we got, let's just retrofit it? How do you make the retrofit or new decision? What are some of the overarching things that you go through trying to decide that?
Put out both sides of this one.
Yeah, maybe since you've been on both sides, why don't you
Yeah.
speak to it, Craig?
So some of the challenges with older equipment is certainly, can you take it out of production to integrate it?
Yep.
And it could be out of production for a couple of weeks or months. A lot easier. It's a lot easier for the integrator to have that piece of equipment on their floor so you can run it off as a full unit. A lot of times, because of production requirements, that's not possible. That causes issues. The other item is controls and just the machine well-being. Been involved in projects where we decided to move the control cabinet. No one told me that there was these hidden bugs, and as we moved the control cabinet, all of them came up. It's like, wait, you didn't tell me about this? Like, did you know about it? So we had weeks onto very tight timeline. And then just the controls talking to one another. This particular piece of equipment was an old slick PLC. They don't talk real well to Ethernet. So there was a whole, the integrator had to be very cautious about how they put it all together. With new equipment, you don't have to worry about those types of things. It's not running production, so you have time to do a proper integration, proper runoff, debug the whole 9 yards. You don't have a lot of legacy issues. And a lot of times, while it looks higher cost up front, sometimes bringing that old equipment up to the new safety standard integration can be still a significant investment. There's a lot of balance, a lot of things to consider.
Yeah, definitely. I didn't even think about like bringing it up to new codes and things. That didn't even cross my mind. Okay. So Matt, do you have thoughts?
Yeah, lots of very similar deals there. You know, it depends on, again, depends on application. We will famously go out and buy old presses, like a 100-ton press, 300-ton press. And because it does one thing only, and it does it really well, and it's really simple. And a controls retrofit for something like that is cake, you know. So we'll go out and buy that, and then we'll make the die set in house. We have a very talented tool and die. We have a couple of EDM machines, so we'll make dies. We'll, you know, send them out to be hardened and then bring them back. And then additional automation beyond that just really depends what it is. You know, we have lasers, robot cells, carousel robots, laser systems with multi-gauge loading tables, roll forming, the trumps, press brakes. We kind of have a lot, and we've kind of discovered what we can and can't buy new and used. I would say the more function that it does, the harder I'd be looking at, or the more scrutiny I would be giving to the older equipment, because it's kind of those, the bugs. I think I heard that. I heard, the tolerances aren't there. You know, you just got to be really careful what the application is.
That's fair. Tom, I'm curious, as an integrator, when someone asks you to retrofit something, how do you handle those kinds of requests?
So we tend to see what they're trying to integrate and do a case by case basis to tell them something we would take on or something we wouldn't. I mean, most of the 95% of the stuff we do is new. If it's integrated, so I mean, a lot of the stuff is, again, the presses we do, we integrate the spot welders, the bolt feeders. I mean, they're all pretty standard stuff. Occasionally, you have some customers say, hey, I have this old piece, you know, this machinery, like, I look at what they're trying to do, what they're trying to accomplish with it, and we kind of make a call on it. But as long as it's safe, right, to run, they're mechanically, and they take ownership over that part of it, we're okay with it.
So for anyone on the panel, Tom, I mean, we can start with you, but I always like to ask a question, because we all make mistakes and none of us are perfect, and we've had chances where something didn't go exactly as planned. I mean, what in your history, not necessarily one of these projects, but you know, what's an automation mistake you made, and what's something you learned from that mistake with automation? Because we're trying to talk people into doing automation. I mean, you're gonna make mistakes and you just have to learn from them, so.
Correct. So in the integration world, you know, it's the old adage, don't get over your skis too much. And prior to being a scout, I spent about 20 years with 2 different integrators, and probably once every few years, we made the cardinal mistake of doing that. And from an integrator standpoint, you know, you take your lessons learned and try to apply them going forward. 2 things that probably usually stood out was not understanding scope of the project to begin with thoroughly, and not necessarily, it may be the integrator's understanding. It's not necessarily the same as the person purchasing the equipment. So just great communication up front, strong kickoff meetings, having a thorough FAT or run off at an integrator standpoint. Hey, integrators, if you're an end user, you never want the integrator to finish the equipment on your floor, because it'll take 3 times as long. It'll cost them twice as much. Your customer is going to be yelling at you to get production out, but the integrator needs the machine to finish the machine. Usually those 2 things: upfront communication, understanding of scope, and never just shipping incomplete equipment. Avoid that at all costs. And if you're an end user, don't push your integrator into that. You're just going to hurt yourself ultimately. So
that's good advice. I think I'll add on to it and I'll pass it on. The one thing I would add is I did a project at my previous employer. I was helping engineer a conveying line, and we were trying to make some dashboards and connectivity, IoT things, and make some fancy stuff. And we did the whole project without ever consulting the IT department. And then IT found out about the project about 3 weeks after it was live, and that did not go well for anybody involved in the project. So I think thinking about who your silent stakeholders are, I think there's core ones. I mean, like someone who's focused on the people, the workers, the operators, someone who's focused on the IT and the infrastructure and some of those things, I think are really important, at least at the beginning, to make sure you're not going to have some sort of impact somewhere in the business you didn't expect. I learned that painfully.
And what's amazing is the largest companies in the world to the smallest, the IT group very rarely talks to the people specing and buying equipment. So that's not the first time I've heard that one.
No.
Or been involved in it.
Yeah.
So
What about you, Greg? They're just trying to keep
I can think of a lot of different things. One of the most difficult positions that I was in the previous automation project was being the general contractor. So I bought material handling carts, bins, and dunnage, none of which I'd ever purchased before, all trying to integrate into a welder and an unload automated cell. And I found myself getting caught in between these different groups and trying to organize various things on the integrator's floor, which becomes very challenging because it's not like you have control over their timing. So one of the best things you can do when you're writing your statement of work is not only going through that detail, but trying to have one point of contact on the integrator side so that they're program managing everything as much as possible.
Good advice. Don't be the general contractor. Yeah. Good advice. What about Matt or Tom? You have a thought on that one? Automation mistake you've made that you'd like to learn?
Good answer.
Okay.
It's a good answer. I think you guys pretty well covered it. You know, you're always going to learn something new there. I yeah, definitely don't presume to think that just because you've done it once that you can then take it in-house and then expect to be successful right away.
Awesome. Okay, so go ahead. We got
I
one more
think
comment.
anyone in automation has made many mistakes. And all of it is just learning and try to deal with a partner who's been down the road to understand, you know, what's going to come up, and communicating with the integrators is important. And I think if an integrator is hesitant, and, you know, I've been on this road many times in taking something on, don't push them to take something on and they don't want to. Okay, so just it's for that's my lesson learned.
Absolutely. No, all good advice. Thanks, everybody. Just if you're still interested in talking about press automation more and how we're going to apply automation in the press shop, I'm actually going to be hosting another panel for Metal Forming Live on July 18th with Todd Wenzel, Paul Stirrett, and Dean Phillips. And I think that'll be a really good continuation to this conversation, talking about how we get the ROI out of automation in the press shop. So please mark your calendar now. You're sitting in front of your computer, throw it on your calendar. Same time, 2 p.m. July 18th, we'll be talking about automation and return on investment on automation in the press shop. So Brad, I'll turn it back over to you. Thanks for the opportunity.
Thank you, Will. And before we close, you know, I guess I want to share two thoughts to leave you with, and they each come, one thought from Jeff and one thought from Matt, and those were in the articles that we did on each of your companies. So I know, Matt, when Lou was up there to do the article on Sukup's automation projects, you told him that, and it's a good reminder, robots don't take jobs away, they enable people to better use their skills. I think that's incredibly true, and we talked about that a little bit today, but I think that's always something to remember. And then, Jeff, when I was visiting you months ago and we talked about this cell, you told me that we need to train great people to do great things for our companies, and I think that's a great thought as well, and I think that falls in line with this project and others moving forward. So that's a wrap then. I want to thank everybody for joining us online today. A huge thanks to our panel for joining us and spending some time sharing your insights and thoughts and such great information. And again, thanks to our sponsors of this Metal Forming Live event for 2023, Co-Press Equipment, Schuler, Sei, Wintris, Greenard, and On Robot. And as Will said, please plan now to join us for our next set of Metal Forming Live events coming up in July, where we will be discussing a variety of topics of importance to metal formers, including automation, again, as well as technology developments related to precision metal forming and the strategies involved in evolving from high mix, low volume stampers to including high mix, low volume metal fabrication operations at your companies. So you can learn more about those events in July on our website, MetalFormingMagazine.com. We hope to see you then. Otherwise, again, thanks everybody for joining us today, and hope you enjoy the rest of your day.